So I lived in the US all of the 1980s, and my life actually revolves around a donut. And that donut is really important to the topic of today. Because I was at Penn State studying operations, I was studying chemical engineering, and I wanted to change. And changed into industrial engineering and operations research, a dual degree at the PhD level. And I had to do a course in OR, and I couldn't work out what courses to do in OR. And I'd come from a chemical engineering where everything was defined by some heavy equation, all partial differential equations, and you had to pull them apart and work out what worked. And there was this thing called discrete event simulation that had to be taken, or was an offer. And the guy said, the woman is really great who teaches this. She brings donuts every Friday afternoon. And I thought, oh my God, that's all I need is some sweet teacher and all of this. I wanted numbers. I wanted hard stuff. So anyway, I took the course because there was nothing else. And what she did, one of the first things she did is said, now imagine at the classroom door, there's a person who's checking IDs. And it takes them approximately 1 minute to check IDs. And people are arriving at that door approximately 1 person per minute. So as a show of hands, how many people believe there will be no line at that door? Okay? So you guys are a lot smarter than I was at that point, right? Because I fought with her for at least a week, trying to prove to her that there would be no line at that door, because it was 1 a minute that the person could check, and they were arriving 1 a minute. And she spent a week persuading me that that line would grow and grow and grow and grow. Okay? So what is the essential element that was making it grow? It's uncertainty. It's approximation. It's that the lead time isn't exactly 1. The processing time isn't exactly 1. And once you've lost a little time on processing, because there wasn't anybody in the queue, you can never gain that time back again. Okay? So uncertainty is a huge factor in all of our lives and in our supply chains. And I want to talk a lot about that today. So a lot more than theory. And what I'm really going to do is poke a little bit of fun at theory. Okay? I'm a theoretician. I love it. I like the maths, but there's a lot more to it than that. Okay, so another show of hands. Before you came to this conference, how many of you had ever heard of Kinaxis? Okay, about 20% at best. Okay, so let me just give you a little bit of an intro. So you can see why we are quite big in the high-tech electronics space, consumer electronics, lots of the big names. There are a number of actually CPG companies that don't allow us to publish their names as customers. So this is a partial list. But nevertheless, our sweet spot is still high-tech electronics, aerospace and defense, this type of industry. Now, what do you think their life cycle of product is compared to CPG? Who knows the average life cycle of a cell phone? Any guesses?
9 months. 6.
3. Oh, well, you unfair. He's in the space. True, some of them are as long as 6, but many of them are down to 3 months. What about a digital camera? And I know that it's kind of a losing market, but a digital camera is often down at about 6 weeks, right? From time of initial sale to beginning of end of life. Okay, so very, very much more dynamic type of environment with many more new product introductions, changing technologies, all of this sort of stuff. It's a very, very dynamic environment in which, the tsunami in Japan absolutely devastated nearly every single semiconductor manufacturer in the world, because over the years they've consolidated, and many of them are either in Taiwan or in Japan. But think about where all of those semiconductors go in the supply chain. That's all over the place, right? If you look at a car, who's bought a car in the last year? And have you noticed all of the electronics in the car? Right? All of this sort of stuff. So it's just amazing. So So anyway, so the central tenet of ours is based upon this idea of uncertainty. So you can't predict the future. So if we go to this one, this is actually a study done by Terra Technologies within the CPG space. And this is their analysis. If you're looking at a 1 month lag by customer by item, the MAPE is around 31%, and that has only improved 5% in the last 8 years. So the real question, if you look at the variation here of 12%, you add that together, that gets you to 47%. Okay? So the worst case, companies have a mean average percent error of forecasting of around about 40–45%. So if you've got that much uncertainty in your demand, how confident are you of your supply plan? Because you're planning against something that you cannot predict. Now if you take it the next step further, within our space, more around high-tech electronics, their mean average percent error of their forecast is 50%, typically. That is a lot of uncertainty that you need to deal with in your supply chain. So the central question is, where are you going to get your next breakthrough of performance? Is it really from trying to plan better? When over the last 8 years you've managed to increase your forecast accuracy by 5%? Or is it really learning how you're going to be able to respond most profitably to the real demand that comes in? Okay? Now this is directly related to inventory optimization, because the question is, what inventory are you going to keep and where are you going to keep it? So let's look at how we are doing, because unfortunately, coming up last or near last in the presentation in a conference, many people have said things before that you wanted to say too, but I'm going to say it anyway. But if we look at around computer hardware, and this is inventory performance, and we see that the two darlings of the space over a period of time have slightly increased their inventory. But if you look at it as a percentage of increase, that's actually one hell of a lot of increase, right? If you look at, which one's, no, that's Dell. If you look at Apple, they're around about 10 days of inventory now, but they're around about 2 in 1999. So that's, what, a 500% increase in inventory? That's a lot of inventory to have increased. But in real terms, of course, it's much smaller. But everybody else is pretty flat, except if you look at HP, they've taken out $10 billion worth of inventory if you work out what their revenue is in today's terms. So that's one heck of a reduction in inventory. And yet, look at their financial numbers. Are they really doing that well? Quite well, but not fantastically. On the other hand, if you look at automotive OEMs, it looks very flat, except if you start looking at Volkswagen, who've increased their inventory incidentally by 10 billion. Now they've made some real decisions on flexibility. I know one chap here is from Germany. I'm not sure if anybody else lives in Europe. Well, in Europe, if you want to buy a car, you typically go to a dealer. There might be one model of each sort of engine size. You go and drive in it. It's black, it's usually black. And you drive around, and then you go and look at all of the colors, and you place your order, and you wait a couple of weeks, sometimes months, to get your car. A very different experience from the US, right? Where you go and walk in, and you say, I want that one. And you drive away with it. Okay? So Volkswagen has been penetrating the US market, and therefore has had to increase their inventories dramatically to be able to deal with that, as well as buying patterns in Europe are changing and all of that sort of stuff. So you can see that there are some real reasons, but the key point is we have been talking about multi-echelon inventory optimization and all sorts of other inventory optimization for many years. There are slides in this deck that include analysis of CPG and other similar industries as yours. But invariably, if you look across, other than some outliers for strategic reasons, the inventories have been pretty flat over that period of time. So what have we been doing? So we've been talking also a lot around the idea of, there's ways in which you design your network, there are ways in which you decide where to place inventory in your network, and then there's the last stage of how you actually execute against your existing network and your inventory displacement decisions against real demand. But demand segmentation falls into that category where you're trying to decide how you need to actually go about placing your inventory. And I think it's really, really important, especially in our space. We've seen this coefficient of variation slide in many cases. I think at least 2 other people have brought it up. I think it's one of the smartest ways of really understanding what your inventory is telling you about. So if you look at the coefficient of variation, this isn't anything to do with forecast. What you're doing is you're looking at how your demand was really, really coming in. So each point here is a skew. It's analyzed over a year. And what they're looking at is saying your mean demand, average monthly volume, the standard deviation of that over the mean is on the x-axis, and the monthly volume is on the y-axis. And the key point here is that 80% of your volume is driven by those items that are above the line, but 80% of your variability is driven by the items to the right of that vertical line. So one of our customers went off and did this analysis for themselves, and they were all very happy. They said, oh, we can just go and trim these items out because they're really difficult to forecast and they're really difficult to manage, and we do this portfolio rationalization that's going to do amazing stuff for us. And then somebody said, hang about, let's just go and analyze those items differently. Let's go and look at them from a margin contribution perspective, not a revenue contribution perspective. And guess what? They found that these items over here contributed more than 50% of their total margin. Okay? So killing that was going to absolutely kill the margin, the profitability. The items up here, had about 10% gross margin. The items down here had about 75, 80% gross margin. So there was no way they were going to get out of this business. What they had to do was change their supply chain to learn how to deal with these items down here. So that was the key question. How would your graph, and you need to be very careful about this, doing this on multidimensional analysis, if you look at it, and in this particular case it was actually units, but if you look at it from revenue and from margin perspective, it makes a big difference in how you would maybe go about deciding how to do this. But in general, the consensus is when you look at this, you need to segment also your supply chain to be able to deliver according to the variability of the demand. So yes, there is definitely a reason to consider rationalizing the items down here, but be careful what you wish for. Okay? But the ones down here with low volume, medium variability, you make to order. The other ones up here, configure to order, FMCG, that's not really possible. I realize that, a bar of soap is a bar of soap. There's not much you can do about it. But for people who have items that you can configure, such as computers or whatever, they have much more capability to move to a configure to order environment. And then the highly repeatable ones with very low variability, you go to make to stock. Okay? But we heard Laura talking about mass customization and other areas such as that. Most certainly within high-tech electronics and consumer electronics, this is a very strong pattern. The long tail is becoming a major, major part of the whole product portfolio. So they can't get away from this. Okay? So notice the items down here have high variability. So who's in a demand planning function? Anybody in here? No one's in demand planning. Okay, sort of. I think we all should be somewhat in demand planning function, but we should at least be able to predict the demand. So what do you think a high variability, coefficient of variation, is going to do to your ability to forecast? Okay? Not going to be good, right? Plus, there's the fact that if you look at this, what you're really doing down here is moving to lower numbers. And forecasting is all about high numbers. Okay? The higher the number, the more predictable it becomes. So this is a big issue with being able to forecast accurately. But HP, way back, and I think this is one of the reasons why they might have been able to show this huge decrease in inventory. They came up with even a more granular perspective. So you take one of those items and maybe you take a product family and a product group, and what you do is you look at the demand and say, okay, how much are we going to have to sell, otherwise we might as well not be in business. Okay? How much are we absolutely going to bet the family jewels on? And then what you do is you put into place a supply chain that is absolutely minimum cost. You don't really need to keep inventory. I mean, they do a lot of manufacturing in China, so they get full containers that get packed in China with complete configuration, all the manuals, and they go directly from China to Walmart. HP never touches them. Okay, full containers. Then you've got this base scenario that you say, okay, this is what we think we really are going to be able to do. And what they do then is ship partially completed PCs over to North America and elsewhere, Europe, etc., and do some late-stage assembly there. But these are pretty much completed items. There's some small variation. In fact, North America is probably not a good example, but if we take Europe, they'll have some place in Germany that will put together a different power cable and different language pack and all of this sort of stuff, different keyboard, depending on where some late-stage requirements are. But of course, the cost of that supply chain is higher than in this particular case. First of all, they're keeping partially completed inventories. They're shipping partially completed items, not completed items, so all of this sort of stuff. And then the high scenario, this is, man, if we hit this, the CEO is going to hit his bonus and everybody's going to be very, very happy, okay? But they almost do speculative buying on this level. They want to go after market share at that level. They're not interested so much in margin. It's about capturing those people because they get so many repeat buys. If a person buys a computer, then they invariably buy that same model next time around. So they're going after market share. They're not so interested in margin. So now this is quite expensive. They almost do final assembly or complete assembly of those components, or they ship them air freight from China or wherever else just to get them into the market space. But, so that's the diagram I drew, okay? Which is great. Well, what if your demand looks like this, where you've got a much lower level of demand that you're absolutely sure of? So now we begin to start talking about new product life cycle, okay? You might think you're going to sell this much, but you have very little evidence that that product is going to go off. This is what you're absolutely confident of. This might be what the product manager is telling you, and this is most certainly what marketing is telling you. So, so how are you going to be able to square these off? And how would you do differently? This is more, in my perception, what fast-moving consumer goods looks like, is in this particular case where you've got much more repeatable demand, and quite honestly, many of your issues are self-inflicted through running promotions and all of this sort of stuff, the fluctuations and variations. But you'd operate your supply chain very, very differently depending on where you are in that space. And high-tech electronics, consumer electronics is in that space mostly. And again, where do you think they're going to get bigger bang for their bucks? Do you think they're ever really going to be able to predict this very, very repeatably? Or do you think they need to actually be able to be much more flexible in their supply chain to respond profitably to real demand? And now when we look at the product lifecycle stuff, this is a great sort of analysis done by Matt Davis, who incidentally came from Dell, where he's looking at different stages of the product lifecycle. I wish I could decompose this and bring it up one line at a time because it would be much more interesting then. But if you look at the green line, that's the profit. So at introduction, you just want to get it on the shelves. You're going to do it any way you like. You can, to make sure you capture this early market. You run it pretty profitably, but then at end of life, you drop down there, and then you might do some late stage EOL selling off to capture some of the profit. Notice this is profit. This isn't revenue. So this is how much you're making from the stuff, but the volume. So the really interesting thing is, when you look at all of this comparison of cost versus flexibility or agility, where should you be at different stages of the life? Okay? So what should you be emphasizing? So a new product introduction, you should be almost entirely over at agility. Forget the cost. Just get the product into market, make sure that it is available for sale. Now, we heard the guy from Sony speaking yesterday, who had a very different approach. But I'd argue that he might be in a more mature type of market where that makes more sense. So this isn't, the same thing for everybody. But really, consider how you're going to adjust your supply chain depending on the life cycle. Now remember, if we go back to the fact that in consumer electronics, this can be as little as 3 months. Now, if you're considering what this means in terms of your inventory levels and where you should keep your inventory, the key message I'm trying to get across is you have to be very, very agile in terms of setting your inventory, checking whether your inventory is right, and adjusting that very, very rapidly. It's not something that you can set and just walk away from for 3 months, 6 months. I think some people were talking about doing this analysis once a year. Well, if you've got a product with a 3-month life cycle, you're going through 4 new product introductions in a year. You can't only visit those inventory levels once a year. Okay? So what I wanted to do is take that variability now and talk about some of the classical inventory optimization methods. Okay? And point out some of the shortcomings. And when I point out the shortcomings, please, I'm not saying don't do anything. We all need to plan. I always relate this to going on vacation. I've got 3 kids, I've got a dog, I've got 2 cats. There's just no way I can decide Friday afternoon, okay, let's go. And go to the airport and see where people are flying. Life just doesn't work that way, okay? So you always need to have a plan, but your plans can go awry. Most of my plans on a personal level hopefully are a little bit more measured than we can see in business. But the key point is, when you're faced with the unexpected, what do you do? And most of the inventory optimization techniques are set up for a much more stable environment than I see in business today. Okay? So if we look at the classic stock calculations, and this was one I dragged off of Wikipedia. There are all sorts of other ones that you can drag off all over the place. Looking at demand rate, lead time, service level, and forecast error. Now, I had a discussion in the break with a chap from Qualcomm who we were talking about forecast error. So I'm actually amazed that forecast error exists in the definition of how much inventory you should be keeping. Because really, I think it's the dynamics of your market and the ability of your supply chain to deliver against that change in demand that is the real thing that you should be using to satisfy or set your inventory policy. It's not your ability to forecast it accurately. Okay? So if we look at some of the standard ones, and that is service factor times forecast error divided by the square root of the lead time. Okay? Question for me, where's the representation of supply variability? So the classic diagram for inventory is you have this nice little sawtooth, very regular, all of this with minimum order quantities. How many people actually think that is a reality, right? I don't think any of you are going to raise your hands to that, right? Yet none of the equations actually, or very few of them, take that into consideration. I'm much more intrigued by this one. The guy just kind of throws these factors out. And he says, well, you go and figure out what they are, but these are the things you should take into consideration. There's this one here, which also comes off from Wikipedia, which actually does consider the supply variability. That's the average lead time and the standard deviation of lead time and all of this sort of stuff. So he does take that into consideration. And then there's the multi-echelon inventory optimization. I don't know what's happened here, but what I put in there is, have you looked at the maths? You know, I've got lots of maths behind me, and queuing theory and all of this sort of stuff, and I find that kind of sometimes a bit difficult to pull apart. But I'll also share with you some pragmatic approaches to that. Why is it not moving? Okay. So what about supply uncertainty? Absolutely key part. We've heard about the tsunami. Well, believe me, in high-tech electronics, consumer electronics, the tsunami is experienced on a daily basis. Not in magnitude, but death by 1,000 cuts. Huge amount of variability. 2008, everybody was just shedding inventory as fast as they could, right? So all the way up the supply chain, especially up into semiconductor. 2009 hit, oh my goodness, the semiconductor manufacturers have mothballed 25% of their capacity. We can't get enough. We can't get enough memory. We can't get enough CPUs, all sorts of stuff they couldn't get enough of. So now everybody was piling on, trying to game the market, trying to capture what was available there. Comes 2011, everybody's putting on the brakes again. Everybody's got inventory squirting out of their ears. So big fluctuations all around supply uncertainty. And then yield uncertainty. That's a big one. We've also worked quite a bit in the pharmaceutical industry. Well, even in semiconductor, they have all sorts of downbinning. So a chip that comes out, I'll tell you about hard drives. So, you know, you can buy a hard drive that's 100 meg and 250 meg and 500 megs and 1 terabyte megs. If you actually pull that hard drive apart, there's probably very little difference in between. What the difference is that certain numbers of those layers of the hard drive had failed inspection. So they downgraded it from a 250 megabyte to 100 megabyte, okay? So this is how this stuff works. The same thing with the chip. They take the same silicon, they do the same writing on it and all of this sort of stuff, and they come out and they do some tests and they say, oh, that's it can go up to 3 gigahertz. But if it fails a 3 gigahertz test, it gets downgraded to a 2.5 gigahertz. And if it doesn't meet the 2.5, it gets downgraded to 1.25, right? So yield is a big thing. So being able to deal with that uncertainty. So the strategies for dealing with supply uncertainty are remarkably the same, including we've heard the discussion around dual sourcing, okay? So those are some of the things. And of course, improved forecasts. Everybody's trying to do that. But it has a big effect on inventory levels if you have high supply uncertainty. Okay, so let's take a classic example. So I just threw this into Excel. I just said, Excel, give me a range of numbers between, I think it was 75 and 125. And let's just pretend that's what our demand is. And then I went off and I said, okay, so what's the coefficient of variation for this number? Again, just through Excel. And this is 0.55. Now, I don't know if you remember on the graph I brought up, but this was the level, 0.5 was at the level at which I did the analysis of 80% of volume and 80% of variability. Okay? That's the center point. But if you look at this, the coefficient of variation of 0.55 is a lot of variability. And some of those graphs, which is real data, by the way, I didn't manufacture that data. The graph that I brought up earlier is real data. Some of those items had a coefficient of variation of 3. So you can imagine what their demand fluctuation is. It's absolutely huge. Okay? So those are the numbers that come out. So what I did was I just then threw some very immature little forecasting methods at it to try and show the fallacy of some of these techniques. So I just threw a flat. I knew that I generated a forecast with an average of 100 because I just said to Excel, give me numbers between 75 and 125. Okay? So I just said, okay, let's just assume one of the forecasts is 100. The naive forecast says, I'm going to assume that my forecast for the next period is always what it was the previous period. And then I just took a 2-period moving average, which in fact I cheated because I used the current period, which of course I wouldn't have known when I was forecasting. But I took the current period plus the previous period and just halved them and came up with this. So you can see what the fluctuation is and the predictability. But then I looked at the root mean square. Flat was 54, the naive was 81, and the moving average came up at 40. Okay? So now what I went and did is look at so that's what I knew was the real number of the forecast, absolutely flat. Okay? And then I wanted to look at lead time and the effect it would have on inventory, sorry, safety stock, not on inventory, safety stock. I want to be clear about that. And just look at the difference. This was using the equation that is the service factor times, the forecast error times the square root of the average lead time. So you see here, if I use the moving average, I never even get it to 100 units of safety stock. Okay, never ever. Or if I take a lead time twice of what my demand period is. Whereas if I include lead time, coefficient of variation for lead time, we can see that it's pushing this up, that you've now got a safety stock of 350 if you've got a long lead time. So it really does impact it, so you really should be including it in any evaluation, provided you've got some variability around your lead times. Okay? So multi-echelon, how do we go about that? So as I said, you know, it's one of the things I studied at the PhD level. What was interesting is I took this course on inventory optimization, 3-month course at Penn State, and it must have been 3 months, it must have been 6-8 weeks in. All of a sudden the guy said, okay, so now what we're going to do is bring in stochasticity. So this was before I'd taken my queuing theory courses and all of this sort of stuff. I was from the deterministic world, right? Chemical engineering, you've got these huge equations, they're always right, and all of this sort of stuff. I had no idea what even the term stochasticity meant. And then he started throwing out all of these equations that needed to include the effect of variability in the way in which you needed to analyze your safety stock and a cycle stock and everything else like that. And then he went on to the next stage and said, well, this is only for a single tier within the supply chain. If you've got a multi-stage supply chain, then he kind of threw on the table a 40-page document and said, okay, this is the maths to deal with that. Okay? But there are pragmatic ways to try and deal with this, and I know that there are some solutions in the house right now and in the space over there that deal with this. Okay? But I came across some of the work by Larry Schneider at Lehigh, which is actually a very clever way of decomposing the whole problem and making it much more consumable. Okay? So some big assumptions, starting from the fact that simply ignore the times that the stage does not meet your committed service time. So, you know, that's kind of a difficult one to swallow. But the key point is that his approach makes it actually very, very easy to try and go through the analysis. So what he's essentially doing is, if you've got 3 stages here, what he's doing is decomposing that multi-echelon thing into multiple echelons. Now I want to emphasize that, you know, those 2 terms mean different things. Multi-echelon means that you're trying to look at all of them across from end to end. Multiple echelons means that you're looking at them singularly but connectedly. So you're not trying to ignore the fact that you've got the connected stages, and this is the indication here. So your net lead time at a stage is the stage previous time, the service time, plus the time of operation minus the time in the previous stage. So bad lead time is the definition over here, good lead time. If you go to here, you can find all of this material. But the interesting point is that when you then decompose it, you come up with exactly the same equation for safety stock as we discussed earlier, right? But he doesn't talk about forecast error, but this is the actual average demand for that stage that would come from the previous stage. So a very clever way of decomposing it into multiple stages and very easy to run through any optimization on Excel or anything else like that. And when you look at it from a hybrid push-pull system, is essentially what the outcome of this system is. So if you've got a multi-stage distribution system, where should you be keeping inventory? And now in FMCG, this is a little bit different, but in guys who do a lot of assembly, a key question related to that is how far back do we keep components so that we still have flexibility in our assembly process to be able to deliver material. So in this particular case, they keep an inventory at these locations and at this location so that they can actually deliver to the customer on average a delivery date of 30 days. Whereas if you actually follow the lead times back through here, the longest component lead time, I think, is this direction, is something like 75 days. Okay? So it's all about how do we postpone assembly of the final product while still being able to provide a lead time to the final customer that's acceptable. Now, again, in FMCG, you guys are a bit challenged because your lead time to the end customer is typically very, very short. Whereas in high-tech electronics, they have more flexibility in being able to provide a longer lead time. Okay, so that's pragmatic, it's very practical, but there are all of these factors. What happens if you have multiple sources for the same item? What happens if you can use a different item as a substitute for an item that you had before? What about if you had a different route, one that is maybe more expensive to get it there in times of emergency? How much inventory would you keep? If you're going through engineering change orders or engineering change notifications, what they affect? Product life cycle, we've talked about that, okay? So there are limitations. But in general, now I've talked to you, and this is key as to why I brought up this question earlier on about the length of the life cycle. Because especially in consumer electronics, the change in the product mix is very frequent through the year. So now you're beginning to think not only at the finished goods level, but the component level, because new technologies are coming in, and you've got to buy different components. But even though at the finished goods level, that's pretty dramatic in how much you're going to be able to store where. And therefore, NPI component requirements, transportation costs. Whose transportation costs have gone down over the year? And believe me, if you're shipping from China to bring the stuff in, it's gone up even more. And the lead times have even gone up more. Okay? So all of this stuff is having a dramatic effect on how much inventory you need, where you need to keep it, all of this sort of stuff. So very few of our customers can find that they can set an inventory policy and just execute against it. It's not sufficient. So our approach to inventory optimization is be pragmatic and be practical. Okay? So there's more to supply chain design than just operations. Okay? All theories are based upon the rule of thumb. All of the inventory optimizations, if you dig down into the maths, ultimately you'll come down to assumptions. Assume this, assume something else, assume something else. Right? There's nothing absolutely correct. Be careful of systems where, and I was a bit worried about, as a software vendor, talking after the guy who talked just before the break. But just be careful of any system where the effort to maintain it is more than the value that you get out of it. Okay? So the last one, again, in our space, demand changes more quickly than the inventory policy, so you've got to be very careful about what you wish for there. So some practical suggestions. Most certainly start with segmentation. Know where your demand is, but as with HP's case, don't just do a blanket segmentation. Drill this down, really understand how your variability is decomposed so that you can then manage your decomposition of that demand in different manners. If you can't actually segment your supply chain, at least understand where your variability is and therefore how much you can attack it. Yes, we all need to plan, but it's what you do once you have planned, and when reality does not match what you had planned, that is when you actually make or break your company. That is when, whether or not you make any profit on that. So convert those ballpark inventory levels into days of supply or weeks of supply, some periods of supply, because that's going to buffer you against a lot of the seasonality. Now, we heard TE talking about this a little bit earlier. Well, what they've got to, I mean, my advice to them would be, well, drive that demand back up your supply chain as quickly as possible. But if you put in inventory policies based upon weeks of supply, and you're driving that from demand, then that will automatically flow the demand all the way back up the supply chain. But if you set it as a fixed inventory level, you're not going to see that flexibility, and you're not going to propagate that demand signal up the supply chain. Okay? With that, I say thank you, and ask for any questions.
Hey, thanks a lot, Trevor. Yeah. Any questions from anyone? Good.
Trevor, you mentioned about the FMCG industry. Based on your experience, what is your suggestion about multi-echelon inventory optimization for a CPG industry where cycle from build to ship to consume is 7 or 8 days? So is it really worth the effort to go after multi-echelon inventory optimization in that kind of a network setting? That's one question. The second question is your assumptions that you said is be pragmatic about assumptions when you're making these kind of computations. We've been struggling with the segmentation part of it, saying how do you segment? What's the best criteria to choose in the FMCG environment? Do you have any insights on that?
Okay. Let me start with the segmentation first. Yes, what I've seen work quite well with the segmentation is actually clustering of customer buying behavior. Okay, so what you're probably going to have to do is do that fairly regionally specific, because you know how customers buy in the Northeast. Again, I'm more from the metal space, but I remember Ford running a promotion on their Mustangs, because they wanted to ship some Mustangs. And what happened is they discovered that indeed they shifted Mustangs, but they were still left with the black ones in Southern California and the red ones in the Northeast. And that was the problem they were trying to solve, because they were not specific enough in the promotion they ran. So when you're doing segmentation, just be very careful about being more detailed enough to be able to understand where those different buying patterns would come from. Okay? But do it from buying patterns, not so much from a product perspective, because that's what often will drive your basket within FMCG. From the multi-echelon stuff, a lot of it is based upon your demand variability and your supply variability. If you've got a fairly stable demand and you've got a fairly stable supply, then indeed things like multi-echelon inventory optimization are going to bring you lots of benefits. Okay? But it's in those cases where you get a lot of demand variability, you're going to be caught short-handed, and very, very often, if you try and apply those types of tools. It's far better to start moving to a pull system where you can propagate that demand much more rapidly up the supply chain, and therefore understand how you're going to be able to realign up and down the supply chain in the short term to satisfy real demand. Okay? It's much more pragmatic to do it in that fashion.
Trevor, thank you so much.